Going to start
Could people hear what
recording.
we're saying now?
They can.
Oh, okay.
Enjoying our conversation.
All
Of
It's
right.
better late to ask.
So let's see here. We are recording. Fantastic. All right. Welcome, everybody. My name is Terry Eichel, and I'm with the Interreligious Eco-Justice Network. This is part of a webinar series that we are offering during this pandemic, and we're very pleased to be able to bring this to you tonight. The Interreligious Eco-Justice Network is a faith-based environmental group in Connecticut. We work with religious communities from all different faith backgrounds on being good stewards of the planet. And so this is part of our program offering. We're glad you are here tonight. We're very excited to feature Doug Tallamy. Wow, he already, sorry.
Yeah, that's right. That's right.
I knew I was right. So very excited to have him here tonight. It's a real honor for us to have someone like this. We've been doing a lot. If you've been following us, we've been doing a lot around pollinator gardens. And so this is sort of the piece de resistance. But first, I would like to introduce our moderator. Here we go. John Marcolon, who some of you may know. He is from, John, you're from Litchfield, correct?
Litchfield, yes.
Yes. And he started teaching after backpacking 7,000 miles and earning a Bachelor's of Arts in Humanities and an MST in Environmental Education. He taught high school science for 33 years at New Milford, Northwest Regional Number 7, and Litchfield High Schools. He taught biology, earth science, and environmental science. From 1992 through 2014, he coached 8 state championship Envirothon teams from 3 different high schools. In 2008, John brought his team to the University of Connecticut for a conference on biodiversity. It was here that he was introduced to the work of Dr. Doug Tallamy from the University of Delaware. Dr. Tallamy's research demonstrates that the quality and type of plants in a landscape have profound effects on the number and diversity of pollinators in that landscape. John was awarded 3 grants to help him start a native plant nursery, create a 1-acre native perennial meadow, and reestablish native woody plants to the forested section of the Litchfield High School campus. Before retiring in June 2020, oh wow, congratulations, that's very recent. John became president of the Litchfield Land Trust and co-founder of the Litchfield Pollinator Pathway. So welcome, John, welcome, Doug. I'm going to, there we go. John, this is Doug's bio. You are welcome to introduce him, and then we'll just let Doug take it away.
Okay, I have never served in this capacity, but I remember, Terry, when you called, you asked, oh, I heard that you know Doug Tallamy. And I said, well, I don't know him in going to a pub and having a beer sense. But since 2008, he's definitely front and center in my work. So in that regard, I definitely know him. When I brought students to the University of Connecticut in a Bringing Nature Home, I think it was Bringing Nature Home tour or something, but it was he was the keynote speaker at a conference, and it was, I don't know, it was some sort of epiphany for me because it was simple, but it was profound. It was addressing the food chains right in our backyard, the types of plants that we use. Can have a profound effect on the bird and the species diversity of birds especially, and insects. So that work really affected the last 12 years of my career. I just finished reading Nature's Best Hope. And Doug referred to, or has a chapter called The Dreamers, where he talks about 2 in particular, Aldo Leopold and E.O. Wilson. And Aldo Leopold, I've read Sant County Almanac a couple of times, and I'm going to pull up the quote from the first line. I have it on my phone here. The first sentence of that book, it says, there are some people who can live without wild things and some who cannot. These essays are the delights and dilemmas of one who cannot. And in that, in 1948, when he wrote that, you can still sense a dichotomy, a separateness of nature from humans, or humans separate from nature. But when I just finished Nature's Best Hope, Doug's most recent book, you could see an evolution of the way he thinks, and hopefully, I think the way we should all be thinking, which is that we're not separate. We are definitely part of this creation. We're part of the evolution of the landscape, and we're part of nature. So as we and Doug is calling us to do and become stewards of our land, stewards of what we see and what we own as land, or land trust, or corporate offices space, or public spaces that we can be stewards for. So it's a tremendous honor to be this person who is saying these things, to introduce somebody who's inspired my work, and I hope will inspire you to make small but meaningful changes in your own backyard. So it's my honor and privilege to introduce Doug Tolomei from University of Delaware.
Wonderful. All right, I'm going to stop my share, and there we go. All right.
Well, thank you, John. And that's a great lead in, because I'm going to disagree with Aldo and say that nobody can live without nature. They may not like it, but they can't live without it. That'll be the main theme for tonight. I want to talk about what I think is nature's best hope. But before I do, I want to remind you what happened not this fall, but a year ago, fall. There was an oak mast all the way from Massachusetts down to Georgia, and in some places as far west as the Mississippi. All the red oaks and the red oak group got together and decided to make their acorns at the same time. And this is what it looked like in a lot of places. Well, if you're easily entertained like I am, maybe you took one of those acorns and just stared at it. I was rewarded when I did that, because an insect started to chew its way out of the acorn. And this is what it looks like in the beginning. They chew a little hole and then force their way through, get the head capsule through, and the body's bigger than the hole, so they kind of look like the Pillsbury Doughboy popping out. Finally plop down on the ground. This is a really dangerous time for this insect larva, because it's really good to eat. Everything wants to eat it. So it's got to get to safety very quickly. And it does that by wriggling and squirming, and gets beneath the ground in about 30 seconds, where it stretches in all different directions and forms a chamber. And then within that chamber, it turns into a pupa, and it stays there for 2 years. After 2 years, comes out as an acorn weevil. Now, a lot of people think weevils have big noses because it looks like they do, but that's actually an extension of the head capsule, and the mouth parts, where's my pointer, are way down here at the end of that extension. They take those mouth parts and chew a hole down into the center of the acorn, turn around and lay an egg in it, and that's how the larva gets down into the center of the acorn, where it can develop in safety. You might wonder why they spend 2 years underground before they come out as an adult. Well, it takes red oak acorns 18 months to complete development. So if they came out the very next year, there wouldn't be enough acorns for them. Of course, after the larva leaves the acorn, it leaves a hole, a true vacuum. We all know nature abhors a vacuum, but in this case, she has filled it with 3 species of Temnothorax ants. These are tiny little ants that make their homes in the vacated holes made by acorn weevils. And if they find a brand new hole in an acorn, they get excited because their old home is falling apart, and they tell everybody time to move. So they grab the larvae and the eggs, and everybody works very hard. In about 30 minutes, they have moved the entire colony into the new acorn. And then they post a guard, make sure nobody uninvited guests come. And that's where they'll live for the next 2 years until this acorn falls apart. Well, about this time, my wife says, what's your point? What are you trying to tell us? I'm trying to tell you that is just one of literally millions of highly specialized interactions that comprise nature. So the interactions between at least 2 different species, where at least one of the species depends on the other one. This is another one, the relationship between jays and oaks all over the world. Jays are the primary disperser of acorns, and it's allowed oaks to move faster than any other tree on the planet, because blue jays are flying up to 2 miles away from the parent tree and burying those acorns. You might wonder what is pollinating witch hazel. You can read in the book, well, it's fungus gnats and flies. But, for years, I look at my witch hazel blooming in the fall, and there's nothing on there, no fungus gnats or flies. Well, it turns out that the major pollinators really are a group of moths called winter moths. Some of them are sallows. This is the bicolored sallow, and it flies very late in the fall. I caught bicolored sallows on Christmas Eve this year, and there was still snow on the ground. So I don't know whether witch hazels bloom late to take advantage of the sallows or whether sallows fly late to take advantage of the witch hazel, but they're certainly taking advantage of each other right now. You're not going to have breeding pileated woodpeckers anywhere near you if you don't have lots of carpenter ants, because that is what they feed their young when they're rearing young. And you won't have carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have this plant, Phacelia. That is the only pollen that that bee can rear its young on. And it turns out that pollen specialization is very common in our native bees. We've got about 4,000 species of native bees, and over a third of them are specialists on particular plant genera. So for example, in this area, we have at least 13 species of bees that can only reproduce on perennial sunflower pollen. You're not going to have Baltimore checker spots unless you have white turtlehead, and on and on. So nature truly is a series of highly specialized relationships. But today, these relationships, nature itself is on the ropes. And it's on the ropes because we did not take Teddy Roosevelt's advice. Way back in 1908, the state of Arizona was planning to mine the Grand Canyon, and Teddy got wind of that. So he went to the canyon and he stood on the edge and looked out over its magnificence. I can never say that word. And he said, leave it as it is. And with those 5 words, he started the process of forming the Grand Canyon National Park. That's great advice, but it's not an option today. There's only about 5% of the lower 48 states that's anything close to the way it was, pristine ecological condition. And that's because we have, we've logged the country repeatedly, we've tilled it, we've drained it, we've grazed it. We have 750 or maybe 770 million acres of rangeland in the US. That's 4.5 times the size of Texas. And of course, we paved it or otherwise developed it. We have straightened our rivers and dammed them, and you can spell that any way you want. We've polluted our skies and changed our climate for centuries to come. We have drained our aquifers. We've brought in more than 3,300 species of plants from other continents, many of which are running amok and changing the species composition of our native plant communities. In short, we have carved up the natural world into tiny remnants of its former self. And each one of those remnants are too small and too isolated from other remnants to sustain the species that run the ecosystems that we all depend on. You might wonder, why have we done this? Well, it's easy to think that our nest, planet Earth, is so big we can foul it forever and there won't be any consequences. But of course, we're wrong if we think that way. And we're seeing those consequences today. And they're making the headlines, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. Washington Post tells us that North America has lost 3 billion birds in the last 50 years. That's a third of the North American bird population gone. As a matter of fact, the UN now predicts that we are slated to lose 1 million species to extinction, possibly within the next 20 years. And I love the way they report this, just as if it's another headline. I mean, they might as well say we're going to lose oxygen in the next 20 years and then go on to the next headline. This is not an option, folks. It is not an option to lose hardly any species, but certainly not 1 million. Well, I could go on talking about the pox that we humans have delivered upon the environment, and thus upon all of our houses, but it's not what this talk is about. This talk is about a cure for that pox. It's a cure that's going to take small efforts from a lot of people, but they will deliver enormous physical, psychological, and environmental benefits to everybody. Let's return to this headline: insect apocalypse is here. What does it mean for the rest of life on Earth? Well, E.O. Wilson, the most famous entomologist probably ever, one of the most famous biologists of our times, Harvard emeritus at this point. He's 92 or 93, still writes a book a year. I could give an entire talk on his extraordinary career. He told us what it would mean if we were to lose insects. And he did it in a paper way back in 1987 called The Little Things That Run the World. And his message was very simple. Life as we know it depends on insects. And if they were to disappear, so would most of the flowering plants. And if most of the flowering plants disappeared, that would so drastically change energy flow through our terrestrial habitats that the food webs that support our animals, the amphibians, the reptiles, the birds, and the mammals, they would all collapse, and our animals would disappear. The biosphere, the living portion of the Earth, would rot because we would have lost insect decomposers that right now rapidly turn over nutrients, and all we would have would be bacteria and fungi. And of course, humans would not survive any of those drastic changes. The good news is that that does not have to happen. We can save our insects, we can save our birds, we can save nature itself, but we're going to have to change the way we landscape in order to do it. Why is that? Well, let me just remind you, I probably don't have to, but we are products of nature. Humans are products of nature. We are totally dependent on what we call ecosystem services produced by healthy ecosystems. In other words, we're not going to live in this planet without lots of other living things to help us out. Here are some of the services that plants give us. And when I say give, they produce ecosystem services that humans use, but so does every other living thing on the planet. How about the production of oxygen? Pretty important. How about clean water? They clean the water, slow its journey to the sea where it's too salty to use. Enormously important one today, carbon capture. Plants are pulling CO2 out of the atmosphere, locking it up in their tissues, and then pumping the extra carbon into the ground. Our soils are brown or black because of the carbon that plant roots have put in the ground. They build topsoil, they hold it in place. They prevent floods, they dampen severe weather, all kinds of important things. What do animals do for plants? Well, they provide pest control services. They pollinate nearly 90% of our flowering plants. They disperse plant seeds and many other things. So designing landscapes like this that destroy the production of ecosystem services, that destroy ecosystems, is not an option. It never was a good option, but today with 7.8, 7.9 billion people on the planet, it's a terrible option. It's not anything. I mean, we can no longer afford to waste parts of the earth in status symbols like this. And there were visionaries through the ages, such as Aldo Leopold, who recognized we need to work on our relationship with planet Earth. Aldo was one of the most eloquent of these visionaries, and he wrote extensively in the first half of the 1900s. One of the things he said was, the oldest task in human history is to live in a piece of land without spoiling it. Now, there are some indigenous groups that have been good at doing that, but our large Western and Asian societies are terrible at doing that. And we consistently extract more from the planet than it has to offer. So we spoil a particular area, then we go to another area and spoil that. And that, of course, is not sustainable. So Aldo had a dream. He dreamt that we humans were actually capable of developing what he called a land ethic. And he wrote about this in Sand County Almanac. In his dream, we would learn to use the land the way we needed to. We would farm it and lumber it and graze and mine and so on. But we would learn how to do it gently. We would learn how to do it without destroying local ecosystems so that it would be a sustainable relationship. And that's what he called the land ethic. What he never talked about, and I'm not sure why, it was developing a land ethic where we actually lived. And again, I don't know why that was, but I suspect that the notion that humans and nature cannot coexist in the same place at the same time was so deeply embedded in the culture of Aldo Leopold's day. It's still embedded in our own culture, that he may not have recognized it as an option. Tonight, I want to argue that living with nature not only is an option, it is now the only viable option left to us. You know, in the past, conservationists worked pretty much exclusively where there were not a lot of people. We need to turn that on its head now, and we need to practice conservation. We need to save nature, recreate nature where there are a lot of people, because that's pretty much every place. In other words, we have to find ways for nature to thrive, not just exist, but thrive in human-dominated landscapes. Where are we going to start? Well, let's go back to private property. We cannot exclude private property from conservation efforts because most of the country is privately owned. East of the Mississippi, 85.6% of the land is privately owned. If we ignored private property, we'd only be dealing with 15% of the land, which is not nearly enough for successful conservation, excuse me. But there are a number of places where we can practice conservation that we haven't thought of as options. How about power and pipeline rights-of-ways? 21 million acres in power and pipeline rights-of-ways. Railroad rights-of-ways, another 3 million acres. Roadsides, 17 million more acres. Golf courses, we've got 2 million acres of golf courses, 3 million acres of airports. The Denver airport is twice the size of Manhattan. These are large areas. And then we have all the places where we live, both in rural areas and suburbia, our cities, hundreds of millions of acres there. If you just add up these sites, and you can think of a lot more, that's 599 million acres. that we could be using for conservation that right now we're really not. How big is 599 million acres? Well, that's bigger than Vermont, plus New Jersey, plus Maine, plus Virginia, New York, Georgia, Florida, Oklahoma, Montana, California, even throw Texas in there. Not having a place to do conservation is not the issue. There's plenty of places we can do conservation. When I talk about conservation, that's probably the wrong word. I'm not talking about finding pristine places and conserving them. We certainly want to do that. But in most places, we've already dismantled most of nature. So I'm talking about putting it back together again. Restoration is probably not the right word either, because people will argue you're never going to put it back exactly the way it was. And they're right. We've changed too many things, but it doesn't mean we can't reconstruct many of those very specialized relationships that are in nature so that we have functioning ecosystems, even if it's not exactly what was there 300 or 400 years ago. To do that, we have to start with the right species. Not all species contribute to ecosystem function equally. So we have to start with the ones that other species depend on. And one of the first things you have to do is reconstruct a food web. Remember, it's plants that are capturing energy from the sun and turning it into food. That is the food that supports all the animals on the planet, with some minor exceptions. But let's just say plants are making all the food. Most vertebrates don't eat plants directly. They eat something that ate plants, and that something is typically insects. And it turns out that caterpillars are the most important group of insects transferring energy from plants to other animals. Actually, the most important group of animals. There's no other animal that transfers more energy to other animals from plants than caterpillars. So imagine what would happen if we took caterpillars out of our ecosystems. Most of the energy would remain locked up in plants. Let me use the Carolina chickadee as an example. We've got a lot of data on chickadees. They are, of course, very common birds that are bird feeders, and everybody thinks they eat seeds. Well, they do eat seeds in the wintertime. About 50% of their diet is seeds. The other 50% is insects, even in the wintertime. But when they're reproducing, it becomes 100% insects. Their babies cannot eat seeds. And they don't take just any insects. If they're in a healthy environment, they will feed their babies exclusively on caterpillars. And it turns out they're not exceptions. 96% of our terrestrial birds rear their young on insects, and most of those insects are caterpillars. So what's special about caterpillars? Well, we'll talk about that. But first, let me give you some data to support what I just said. There's lots of sources of data, but this is a citizen science project that one of my PhD students did. She finished a couple of years ago. She put out a call for bird photographers to take pictures of birds during the breeding season when they were carrying food to the nest. The object was to send these pictures to Ashley, and she would identify the prey item. And they did. They sent thousands of pictures to Ashley. I don't know if I told your name. Ashley Kennedy is who it was. So that she could reconstruct the nestling diet of the major bird families in North America, terrestrial bird families. So that's what you're looking at here. The green bars are the percentage of these bird families' diets that are caterpillars. And in 16 out of the 20 families, caterpillars dominate the nestling diet. So again, what would happen if we took caterpillars out of the system? Most of our terrestrial birds would not be able to breed. So now we'll talk about what is special about caterpillars. There are a lot of other insects out there, but caterpillars are certainly being favored. There are several things special about caterpillars, and one of them is they are soft. So think of this caterpillar as if it's a little sausage with a very thin wrapper. The thin wrapper is exoskeleton. It's cuticle. It's undigestible. And birds don't want a lot of things that are undigestible. And because it's soft, that means they can stuff it down the throat of their offspring without fear of injuring them. And if you've ever watched a parent bird feed its young, they're pretty rough. They take that beak and just stuff it down there like a plunger. And they don't have to worry about injuring the esophagus. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our smaller birds do chase aphids around, but do you want to chase 200 aphids or get one caterpillar? They're very nutritious. They're high in protein, high in fat. They have a low percentage of chitin compared to most other insects, particularly beetles, which are not like little sausages. They're like little tanks. So a lot of a beetle is undigestible, and they also have a lot of sharp edges. And finally, it turns out the caterpillars are the best source of carotenoids for birds during the breeding season. Why do I talk about carotenoids? Not because I love organic chemistry, but because I am a vertebrate. And you're a vertebrate and birds are vertebrates. And vertebrates cannot make their own carotenoids. They have to get them from plants, and they have to get them from plants because carotenoids are essential components of our diets. And that's why my wife Cindy says I have to eat my carrots to get my beta carotene. I have to eat my tomatoes to get my lycopene, my whatever that is to get my lutein. And she makes sure I eat all of those things because they stimulate my immune system. And I cannot think of a better time to have a strong immune system. They're also antioxidants. They run around our body, protect our DNA from oxidative damage. They improve color vision. When your mother said, eat your carrots, you will see better, she was right. She didn't know she was right, but it turns out she was right. They improve sperm vitality, improve sexual attractiveness. Now we're talking about things like this male prothonotary warbler, who is bright yellow because he has had access to lots of luteins. He takes those luteins, makes pigments out of them, puts them in his feathers, and the brighter yellow he is, the more ladies he attracts. Well, where are they getting their carotenoids from? They're getting them, of course, from their diet, but carotenoids are not equally distributed among bird prey items. These first two bars here are types of caterpillars. They have far more carotenoids than other types of insects and invertebrates. The third bar are orthopteroids, things like crickets, grasshoppers, and katydids. Here are the adult caterpillars down here, the moths and the butterflies themselves. Far fewer carotenoids because they're not eating green leaves. That's where the carotenoids are. It's the caterpillars that ate the green leaves. And here's the earthworm way down here. The early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. Does this influence prey choice when birds are foraging for their young? Well, Ashley did another study with bluebirds. She took GoPro cameras and put them on the roofs of bluebird boxes, and those cameras took a picture once every second. And the object was to catch the bluebird as it was flying into the house and get a picture that's good enough to identify what was in its beak. And she had a lot of GoPro cameras and a lot of bluebird houses, and she did it for 3 years. So she had over 1 million pictures to go through. But out of those pictures, she got 7,628 that were good enough so she could identify what the prey item was. And she got a very nice relationship between the prey items that had the highest amount of carotenoids and were brought back most frequently. Caterpillars had more than anything else, and they were brought back the most, followed by those orthopteroids, and then everybody else was nestled down here in the other end. So this suggests that the carotenoid content may be one of the factors that birds are using when they choose prey items. All this is saying is that caterpillars may not be optional parts of bird diets. It's looking like they are essential parts of bird diets. So let's just say birds need caterpillars. Okay, how many caterpillars do they need? 1 or 2? Is that good enough? Well, again, let's go to chickadees. Got a lot of data on chickadees. No, 1 or 2 is not enough. It takes 6,000 to 9,000 caterpillars to make 1 clutch of chickadees to get them to the point where they leave the nest. After they leave the nest, the parent continues to feed them caterpillars for another 21 days. So it's many, many thousands of caterpillars required to make a clutch of a bird that's 1/3 of an ounce. Now, chickadees, if you want chickadees to breed in your yard, and you do, because that's what we have is yards these days, you have to have thousands of caterpillars in your yard because they're not going to fly 5 miles down the road to the nearest woodlot. They forage about 50 meters from the nest. And if you don't landscape in a way that has all these caterpillars in your yard, that's called insect decline. And it's really looking like that's one of the major factors causing bird declines. We went to the original data that Rosenberg et al. Published when 2019, when they said we've lost 3 billion birds in the last 50 years. And we divided the birds, terrestrial birds in North America, up into 2 groups. The birds for which insects are essential at some part of their life history, and bird species that don't require insects, things like the doves and finches that can reproduce entirely on seed. They actually gained some numbers in the last 50 years. But the birds that require insects lost on average 10 million individuals per species. This doesn't prove cause and effect, but it certainly is suggestive that there's a very tight relationship between the health of insect populations and the health of the birds that require them. So let's just say birds need caterpillars. That's not a giant leap to make that statement, which means we have to start landscaping for caterpillars if we want to have birds. And that's an entirely different approach to landscaping than we've done in the last forever. Because we've considered our landscape plants to be decorations. We don't want anything to eat them. But we're going to change that. They don't eat that much of them. We need to make caterpillars. And the way to do that is to add the plants that support caterpillars to our landscapes. Seems easy enough, but there is a catch, and that is that most plants don't support a lot of caterpillars. It's very easy to get ones that aren't eaten very, very much. So how do we find the ones that are eaten a lot, and why do we need to? We need to because most caterpillars are really fussy about what they eat. Here's the monarch butterfly. If you want to have monarch butterflies, if you want to make monarch butterflies in your yard, you can have all the crepe myrtles and boxwoods and burning bushes and hostas and any other plant from Asia that you want, and you won't make a single monarch because they only eat milkweeds. That's called host plant specialization. And most of the insects that eat plants are host plant specialists, just like monarchs. Why? Because plants have made them that way. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they've loaded their leaves with nasty tasting chemicals that make them either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there in the summertime. It's not because there are no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. If you don't believe me, next summer, go out and grab a plant and eat it. See if you like it. You're not going to like it. There's a reason it's hard to get our kids to eat their vegetables. They inherently know they're toxic. That's my little joke. This is not a joke. Insects do eat plants. How do they do that? How do they get around these chemical defenses? Well, that's where the specialization comes in. 90% of the insects that eat plant can only eat a very few plant lineages for which they have developed the adaptations that allow them to get around those plant defenses, allows them to eat those plants without dying. They develop enzymes that store and excrete and detoxify those compounds, behavioral adaptations, life history adaptations that minimize their exposure to those compounds. But all plants are protecting themselves differently. So the insects can't adapt to all those defenses. So they pick one or two plant lineages and get really good at that. That's what the host plant specialization is all about. And that's why our insects are so poor at eating plants from other continents. Those plants haven't been here nearly long enough for our insects to adapt to them. Point is, plant choice matters. If we're trying to build food webs that support the life around us, where we've already dismantled them, we've got to choose the plants that are going to succeed. All plants don't do it. And I'm going to give you 3 examples of how easy this is and how well it works. Starting with our own house here. This is where Cindy and I live. I am sitting in that window right now. And this is what it looked like when we moved in. It was house was built on a farm that was split up into 10-acre lots in Oxford, Pennsylvania. And it was an old farm. The land had been farmed for just about 300 years. The last thing they did was to mow it for hay. But when you mow for hay in this area, you're really mowing a bunch of invasive species: multiflora rose and Oriental bittersweet and autumn olive and Japanese honeysuckle. And then you call that hay. So when they stopped mowing and we built the house, all the rootstocks of those guys came back like crazy. And this is what the 10 acres looked like. It was this giant tangle of plants from Asia. That is Cindy. She's getting ready to get rid of all of this stuff, which she has done. So if you have a serious invasive problem, and most people do, don't give up. If Cindy can do it, you can do it. I helped a little bit, but not that much. What was I doing in the meantime? I was telling her she was doing a great job, but I also was putting the plants back, and I did it in a selfish way. My little hobby is to take pictures of caterpillars I've never seen before. So I put plants back, hoping I would attract species that I'd never seen, species that used to be here, but have been gone for hundreds of years, like the Canadian owlet. We didn't have any Canadian owlets. That's what the adult looks like, because we didn't have its host plant, meadow rue. The meadow rue used to be here, but long gone. So I got some meadow rue seeds from someplace and planted them. I don't know where there's any meadow rue even close to us. They grew nicely, but this was early on. I wasn't at all sure that Canadian owlets would ever find my meadow rue planting. So I didn't go out and check those plants for about a month and a half. Finally, I walked by one, and it was almost defoliated with Canadian owlets. They had found it right away. I was amazed. So now I have a good population of Canadian owlets and meadow rue. So there you go. We've added 2 species to the property because we added meadow rue. Same thing with the goldenrod stowaway. That's a misnomer. This beautiful moth has nothing to do with goldenrod. It's a specialist on this plant, Biden's Aristosa ditch daisy. I did know where there were some Biden's seeds in a power line cut about 14 miles away. Went and got those seeds, planted them at home. They grew very nicely. Took about a year for the goldenrod stowaway to find our Bidens, but they did. And now we've got a good population of those two. So now we've added 4 species. Wanted the hackberry emperor because it's a butterfly that should be on our property. This is where it should live. But as its name suggests, it's a specialist on hackberry, and we didn't have any hackberry. So I planted hackberry. This took 3-4 years for the butterflies to find it, but good populations now. I walked by one of my hackberries this June. There were 9 hackberry emperor butterflies on a single branch. So that worked really well. There you go. We added 6 species. I did not plant goldenrod, came in on its own, and so did many of the things that eat goldenrod, like the brown-hooded owlet, the Arcigera flower moth, the goldenrod leaf miner, the distinct Sparaginothus, the goldenrod gall moth. Here's one that has not come, the goldenrod flower moth, and its larvae. I don't know why. Should be here. It's not here. So this is anticipation. Every year I go out and look for the goldenrod flower moth. It's like waiting for the ketchup to come out of the bottle. One of these years, it's going to happen, and it'll be a great day. I planted Virginia creeper because, well, it's a good plant. I don't know why people don't like it. You can climb our trees without pulling them down. Got good fall color, and it's a wonderful host plant for caterpillars, particularly sphinx moths, things like the beautiful Pandora sphinx and its great adult. The lettered sphinx, the hog sphinx, the abbot sphinx all depend on Virginia creeper. I wanted to see if we could get the zebra swallowtail. I think it's our prettiest swallowtail, but I was pushing it here because we're at the northern limit of zebra swallowtails. It's a specialist on pawpaw. So we planted pawpaw, but the nearest population of zebra swallowtails that I know of is 26 miles south of us. And I just didn't know if they would come this far north. We waited 9 years, but then they came. They came after 9 years. In the meantime, we got the pawpaw sphinx. I didn't even know there was a pawpaw sphinx, and lots of pawpaws. Wanted the double tooth prominent because I just think it's a really cool looking caterpillar. I wanted to take its picture. It's on elm. So we planted American elm. It's doing very well. They both came. Wanted the evening primrose moth because it's a beautiful moth. I like beauty just like anybody else. So we planted evening primrose, and it has a great habit of hiding in the flowers like this. This reminds me of how my daughter used to play hide and seek. She just covered her eyes and thought we couldn't see her. But you find them during the day this way, so you know that you have them. And we planted lots of oaks. Now, these are just examples of the plant lineages that we've added to our property. We've added a lot more than that, but I want to focus on oaks for a while because they're such important plants. This is the Bedford oak in Bedford, New York. Some of you have probably seen it, I'm sure. It's enormous. People argue about whether it's 400 years old or 500 years old. But you know, it illustrates, a lot of people think your oak has to be enormous before it can really contribute. I hear all the time, I'm not going to plant an oak because I won't live long enough to enjoy it. Well, unless you die the next year, you can enjoy it. And I can say that with confidence because I planted most of my oaks as acorns or as 2-foot bare root whips. So they were free. They grew rapidly, but right away they started to contribute to the food webs that are creating the life forms in our yard by supporting things like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth, the orange-headed epicalema, the red-washed caterpillar, the yellow-vested moth, the orange-tufted oneida, the spiny oak caterpillar, the two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the orange-humped oakworm, the pink-striped oakworm, the delightful dagger moth, the pleasant dagger moth, the lesser oak dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the white blotch heterocampa, the oblique heterocampa, the red-line panapoda, the laugher, and literally hundreds more moth species have come to the oaks on our property, and they come right away. This is a crocus geometer standing on the ground and eating the leaves of a pin oak that has just popped its head above the surface. So you don't have to wait a long time for your oaks to start to bring life and a lot of joy to your property. This is a picture of our property from the same perspective I took that earlier one. I'm still sitting in this window right here, just to show you, we're traditional. We got front lawn there, but we put a lot of plants back. and I'm sure we have not put all the plants back that were here originally, but we keep adding plant lineages. And every time we do, new groups of moths come. And I made it a goal 4 years ago to start to take pictures of every species of moth I could find on our property, just to see how much biodiversity we've created. I am up to 1,030 species of moths so far. I added over 100 last year. So there's still a lot more to go. Haven't even gotten to the butterflies yet. Now, we have 10 acres in Pennsylvania. Well, Pennsylvania is 2.4 million acres. So on 1/240,000th of the land area of Pennsylvania, we have 38% of all the moth species that occur in Pennsylvania. And because each one of these species is a type of bird food, we've had 59 species of terrestrial birds breed on our 10 acre, which is 40% of all the terrestrial birds that breed in Pennsylvania. I'm telling you this just to illustrate that it works. September 11th, we saw this headline. World Wildlife Fund says 2/3 of wildlife has vanished from Earth since 1970. And I'm thinking, not at our house. I am sure that we have increased biodiversity by more than 2/3 at our house simply by putting the plants back. So this is reversible. It's so important to recognize. Don't give up. Put the plants back, and we can save so much of what is disappearing in other parts of the world. But I know what you're thinking. I've got 10 acres. Maybe you don't have 10 acres. Will it work on smaller properties in, say, suburban landscapes? Let's go to Margie and Dan Terpstra's house in Kirkwood, Missouri. They have 0.6 acres, 18 times less area than Cindy and I have. The major invasive species in Kirkwood, Missouri is bush honeysuckle. So the first thing they did was get rid of their bush honeysuckle. They're surrounded by neighbors, by the way, with the big lawns and the typical suburban look. But they got rid of their bush honeysuckle. They put in a lot of native plants and a feature they call a bubbler. A little bubbler comes out of the rock here and splashes down. And then they sat back and started to count the birds that use their property. They're up to 149 bird species that have used their property, 35 warbler species. Just to put that in perspective, we've only recorded 8 warbler species at our house. So yes, it works on 0.6 acres as well. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago, right over that wall there is one of the runways for O'Hare Airport. Right over here is Kennedy Expressway. And she has 1/10 of an acre, which is 3 times smaller than the average lot size in the US. Well, she did the same thing. She got rid of her invasive species. She planted 60 species of native plants, put in a water feature for her birds, and then she sat back and started counting the birds that have used her property, and she's up to 116 species of birds that have used her yard, including a woodcock. There's Pam's woodcock. If you haven't seen a woodcock lately, you can go to Pam's house in Chicago and check it out. And I might emphasize, she's an island. There is no connectivity with any other natural area and her property. So little properties can work. What about city centers though? 82% of us live in a city. Well, in 2014, I was staring at this plant, Asclepias tuberosa. People call it butterfly weed, but that reminds me, we've got a terrible marketing issue with our native plants. We call them weeds and wonder why people don't plant them. So we're not going to call this butterfly weed anymore. We're going to call it Monarch's Delight. I was staring at Monarch's Delight, and the first thing I saw was 2 species of leafcutter bees. I know that these are leafcutter bees because they carry pollen. Where's my pointer? They carry pollen on their tummy, not on their legs. Well, leafcutter bees have very specific requirements. Not only do they require pollen and nectar, but they also require soft leaves. Leaves like are found on redbud, because they cut the edges of those leaves out, roll them up into tubes and stuff them full of pollen and put that whole package into a crack or crevice. Then they lay an egg on it, and that's where their larvae develop. Well, there was a redbud growing right next to Monarch's Delight, and that explains why there were megachilid bees there. There were also bumblebees there, and I'm going to give credit to the redbud again, because remember, bumblebee queens overwinter alone. They don't have a colony. So when they come out in the spring, they have to do all the work themselves. There are no workers. So they need a lot of very efficient forage available early on, and redbud flowers right away, or their colony fails. There were bumblebees there. And then I saw 2 monarchs on the Monarch's Delight. Now, this was 2014. In 2013, I had gone the entire year without seeing any monarchs. That was the low point of the monarch population in the East. Only 3.6% of the monarchs left. So I was very pleased. And this was June. It's hard, monarchs don't get this far north in June very often. So this was a good sign, good start to 2014. Why were they there? Well, there was Monarch's Delight, but there were other milkweeds there too. I think this is purple milkweed. So they had forage, but they also had host plants so they could reproduce. Do you know where I was? I was on the High Line in the middle of Manhattan. I was 30 feet above the taxis and the cement, right in the middle of construction, right in the middle of millions of people that visit the High Line every year. It, of course, it's an elevated railroad that was abandoned, and somebody went up some years ago and saw that most of the plants up there were native plants that had seeded themselves in. So they said, let's make this a tourist destination, and they did. But this is the planning here. It's not huge. There's the Monarch's Delight. This is Rick Dark. He was after me to go to the High Line and check out all the great plants. I'm not much of a city boy, so I dragged my feet, but finally he got me there. I thought I'd say, okay, a bunch of pretty plants, but nothing would be on them. I couldn't imagine anything finding this small little resource in the middle of Manhattan, but I was totally wrong. Somebody's just finished a survey of the bees of the High Line. They're up to 30 species that have found the High Line. So it convinced me if thoughtful native plantings, and the High Line is not entirely native either, but if thoughtful native plantings can bring life back to the middle of Manhattan, then we can do this anywhere. This can succeed anywhere. But there are 4 things we need to think about to succeed in a big way. And one of them is we've got to shrink the area that's in lawn. We have 40 million acres, more than 40 million acres in lawn right now. And of course, the way we treat our lawn, it's a deadscape. That's the size of New England, folks. This is not a small area that we have allocated to a status symbol. So I'm just saying, let's reduce the area of lawn. We won't get rid of the status symbol. I mean, it still shows that we're good citizens. We're following the rules. We can keep it manicured, but let's take half the area out of lawn and replant the other half. If we do that, we'll be working with 20 million acres that we could put towards conservation. And if we do it at home, we can create a new national park that we can call Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Bands National Park, Olympic National Park, Sequoia National Park, plus the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. And when we do that, when we recreate part of the natural world right where we live, it allows us to develop either for the first time or refresh an old childhood relationship with the natural world. And we can do it at our own time and our own pace. We can avoid crowds. I mean, if you go to a real national park, millions of people there. There's also a fee. You don't have to pay to see the nature in your yard. No travel hassles. It's never closed because of a pandemic. You can always go out. You get to experience the natural world alone. And this is really important, particularly for our kids. That's how they develop that personal relationship, which, by the way, they have to do because they're going to be the future stewards of the planet. And if they don't have a relationship with the stuff they're supposed to be stewarding, they're not going to have any motivation to do it, and they're not going to know how to do it. So Richard Luce says our kids are suffering from nature deficit disorder because they don't have any experience with the natural world. So, what do? We're putting them on a bus, get 30 kids on a bus with a teacher, and they drive for an hour and go to a natural place and walk around. And then the teacher tells them not to touch anything. They get back on the bus and they drive home. And that's their experience with the natural world. I am sure that is better than nothing. But what it's really been an experience with is 30 other kids and a teacher telling them not to touch anything. If they have the natural world where they live, they can go outside and experience alone, no parental supervision. Let them test the world all by themselves, see if they survive. I bet they will. And they may even learn how to hunt lizards. I'm learning that from my own granddaughter, Zoe, who lives in Hawaii. And her patch of nature is pretty small. It's like a 10 by 10 foot piece of grass with a hedge, but there are anole lizards there. So this is how you hunt lizards, according to Zoe. You cover yourself with sticks and grass and leaves so that the lizards don't see you coming. And then you crawl very slowly on the ground toward the lizard. No smiling. This is serious stuff. You can wear your best dress, that's okay. But the object is to sneak up on the lizard, catch the lizard, and then put it in an aquarium. And you've got that personal relationship with another living thing. Now, I don't think Zoe's going to be catching lizards in Hawaii for the rest of her life, but I guarantee she will remember catching lizards when she was a little girl. If you want to do more than catch lizards, get this book, Nancy Stranisti's Nature Play at Home. Dozens of examples of things that your kids can be experiencing in right where they live. So we've actually started we've started Homegrown National Park, and you are allowed to join it. You can go to our new website, homegrownnationalpark.org. You can get on the map. You put in your data where you've added native plants to your yard, and your little part of the U.S. is going to light up. And the object is to see the whole place light up, or at least 20 million acres of it. We could see biological corridors form, trying to get beyond the choir to convince people that, this is something we all have to do, and we're giving this a try to see if it'll work. So far, so good. All right, we're going to shrink the lawn. What are we going to put in the area of the lawn we take out of grass? I suggest we put keystone plants there. This is maybe the most important thing we've discovered in our lab in recent years, and that is that not all native plants are contributing equally to food webs. About 5% of our native plants are making about 75% of the caterpillar food that drives these food webs. 14% of our native plants are making 90% of the caterpillar food that drives these food webs. So I'm calling those keystone plants. It turns out, that means 85% of our plants are not delivering all that much. Remember, a keystone is that center stone in a Roman arch. If you take the center stone out, the arch falls apart. If you take these keystone plants out of a food web, it falls apart. So the question is no longer simply, are natives better than non-natives? On average, they certainly are. But it's easy to construct an all-native landscape that doesn't do that much. And that's not the goal. The goal is to put ecologically productive plants into our landscapes. Make sure they're there. There can be other plants as well, but these guys have to be there. And they certainly have to be there more frequently than ecologically destructive plants. We just can't tolerate those invasive plants like burning bush, like barberry, like calorie pear that escape our yards and biologically pollute all the land around us. I get an email once or twice a year from somebody saying, don't you know that ginkgos from Asia, Ginkgo biloba, actually grew in North America 7 million years ago? That makes them native. That means we can plant them and everything will be great. Yes, I do know that ginkgos grew in North America 7 million years ago. We can argue about whether that makes them native today, but I'm not going to bother because that's not our metric anymore. Our metric is how productive they are. I don't care if ginkgos grew on the moon 7 million years ago. They support 0 species of caterpillars. They are not productive at all in terms of supporting food webs. What is productive? Oaks are the most productive plant genus in this country. 557 species of caterpillars in the mid-Atlantic states, and that includes Connecticut. That's 557 species of bird food supported by oaks. Over 900 species nationwide. No other plant genus comes close to that. Let's look at what keystone oaks are doing in my yard based on the numbers that I have so far. Remember, I've recorded 1,030 moss species so far in my yard. Haven't gotten to the butterflies yet. We'll get there. Out of that 1,030 species, 906 have known host plants. Out of the 906, 267 species use oaks. And we got 69 genera of native plants, native woody plants on our property. And only one of those is the genus Quercus, the oaks. Excuse me. My dinner. And we had hundreds of genera of herbaceous plants. So oaks represent less than 1.5% of all the woody plant diversity on our property and way less than 1% of all the plant diversity, total plant diversity on our property. But they're supporting almost 30% of all the moss species on our property. That's the power of a keystone plant. Imagine what would happen to the species diversity of our yard if we took oaks away. How do you find out what the native plant, the keystone plants are for where you live? You go to Native Plant Finder, National Wildlife Federation website, and you put in your zip code, and the ranked list of both the woody and herbaceous plant genera that are best at supporting food webs will pop up. So this is what a typical list would look like for our area here. Oaks are almost always at the top. As a matter of fact, oaks are at the top at 84% of the counties of North America, if I didn't say that already. Notice I say native oaks, native cherries, native willows, native birches, native maples. If you go to the nursery and say, I want to buy a maple, they'll probably sell you a Japanese maple. I want to buy a birch, they'll sell you a European weeping birch. If you want to buy a willow, here's a weeping willow from the Middle East. Same with cherries. Even a good chance if you say, I want to buy an oak, they might give you a Chinese oak or English oak. Specify that you want a native member of this genus. Even though it's a native genus, when you get a non-native member, it reduces caterpillar use by 65%. We've measured it. These are the best herbaceous plant genera. Goldenrods are always way up there. Asters are high. Sunflowers are high. Those 3 genera alone support over 40 species of native bees that won't be in your yard if you don't have those three genera, and lots of species of caterpillars as well. Okay, we're going to shrink the lawn, put in keystone plants. A lot of insects are going to come to our yard, and then we're going to kill them with our security lights at night. And of course, that is not the goal. It turns out that light pollution is one of the major factors reducing insect populations, at least in temperate zones around the world. A lot of this research is coming from Europe, but there are many ways that lights kill insects at night, particularly moths. You know, the moth flies around the light till it dies of exhaustion. It collides with the light and dies. It gets incinerated, dies of dehydration. The bat comes and eats it. Bright lights at night blind a lot of night insects. Who knew? And it keeps them from doing what they need to be doing, finding mates and reproducing and so on. This is actually really good news to me, because if it turns out that light pollution is a major cause of insect declines, which is, can't have insects decline, that's a disaster. Light pollution is one of the easiest things to turn around. Just turn off the light, flick the switch. And I know what you're going to say. I can't do that because the bad man will come. Okay, put a motion sensor on your light so it only turns on when the bad man does come. And the first thing you're going to find out is the bad man doesn't come very often. If you don't want to do that, take the white light out of your security light, and mercury vapor bulbs are the very worst, and put in a yellow bulb. Yellow wavelengths, particularly yellow LED lights, are the least attractive to night flying insects. If we switched out our night lights with yellow LED lights overnight, we would save billions of insects and probably billions of dollars of energy as well. Seems like a no-brainer. The fourth thing we need to do is to landscape in a way that allows caterpillars to complete their development. What do I mean by that? Well, I live in Chester County, Pennsylvania, and in Chester County, Pennsylvania, 511 species of caterpillars develop on oaks. A few of them, like the Polyphemus moth, complete their development on the tree itself. The caterpillar eats the leaves, it spins a cocoon, hangs from a branch, then the adult emerges and it does it again. I wish everything did that, but most species don't. 480 species, 94% of them drop from the tree, wiggle their way beneath the ground as caterpillars and pupate underground, or they spin a cocoon in the leaf litter under the tree. And that's the problem. There is no leaf litter under the tree, and the ground is compacted and mowed and as hard as a rock, so the caterpillars can't get beneath the ground. So the adult moths come in, lay their eggs, the caterpillars develop and fall down here and die. And the next generation is smaller, and the generation after that is gone altogether. I am convinced that this type of landscaping is a major cause of insect declines. And of course, cement landscaping is even less of a viable option. I'm not trying to discourage the use of trees in cities. I am trying to discourage the profligate use of cement in cities as a default landscape. That's laziness, and it ruins our watersheds. We know that. This is what most people do. You got a big lawn, you put a tree in the middle of it. Nobody's measured what the caterpillar survivorship is in a situation like this, but I guarantee it is higher in a situation like this. We have a tree, then you have a layered landscape, maybe a dogwood over here, native azalea and ferns and ground cover. The caterpillar drops down into a safe site. The soil is very loose. It can easily get beneath the ground and pupate, spin a cocoon in the leaves. Nobody's going to walk on it. Nobody's going to mow it. Have very high caterpillar development. This is where you do your spring ephemeral gardening. Make a bed around your tree. That's how you can shrink your lawn. That's a major way to shrink your lawn and have lots of beautiful plants. Again, safe site for those caterpillars. This is where you can use ground covers like wild ginger or mayapple or foam flower or native pachysandras. Lots of options there. Ferns, great options. This is in a hotel, but look at all the areas where caterpillars could survive. Another grad student, Desiree Narango, worked with Carolina chickadees in the suburbs of Washington, D.C. And she asked a simple question: how well are chickadee populations sustained in landscapes that are dominated by non-native plants versus landscapes dominated by native plants? And the results of her study suggest there is room for compromise in our plant choices, which is good news to me. When she looked at what was happening in landscapes dominated by non-native plants, the first thing she found is they produce 75% fewer caterpillars. So you reduce chickadee food by 75% right away. They were 60% less likely to have breeding chickadees at all. There's a nest box up there, but the chickadees would come look around, and somehow they knew there's not enough food here to rear their offspring, so they wouldn't breed. If they did breed, those nests contained 1.5 fewer eggs. Those clutches were 29% less likely to survive. If they did survive, the nest produced 1.2 fewer fledglings, and maturation was delayed by 1.5 days. You might say, well, those aren't huge differences. But if you put all that together in a population growth model, as a function of the percentage of non-native woody plant biomass, from none to 100% non-native woody plant biomass in your yard, this is what you get. The dotted line is replacement rate. This is the rate at which the population has to make babies in order to replace the adults that die every year. If you make babies at that rate, it's a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, you have a growing population. But if you make fewer, you got a shrinking population. Right here is where those lines overlap, which suggests you can have up to 30% of your woody plant biomass non-natives before you get into the area where it's unsustainable. In other words, if at least 70% of your plant biomass is native, you can have sustainable chickadee reproduction, and there's no reason why this wouldn't apply to other birds as well. It also suggests that this is the area of compromise. And again, that's good news to me, because it means you can have your ginkgo, you can have your crepe myrtle. You can't have any invasive plants. We got to get rid of the invasive plants because that's biological pollution. But as long as they're not dominating your landscape, as long as most of your woody plant biomass is native. The reason we're talking about woody plant biomass here is because that's where chickadees forage, on woody plants. So good news to me, because if my message was that you can't have any non-native plants, nobody would listen, because everybody loves their non-native plants. Remember, it is not the presence of non-native plants that destroys food webs. It's the absence of native plants. You can have both as long as most of them are native. Can native plants be used in formal designs? Of course they can. This is a growing garden in North Carolina. They're sending me these pictures. They've added Joe Pye. Notice I didn't call it Joe Pye weed. It's not a weed. And they're going to replace all these plants with native plants, just to demonstrate that you can have a formal garden that is built of natives. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe all the time. And I guess that's okay because they're non-native plants there. Can we get a pollinator garden into a traditional suburban neighborhood like this without offending anybody? Of course we can. Just put a fence around it. Simple little fence. It shows it's intentional. It's not a bunch of weeds. It's beautiful. And it's servicing several species of native bees. It's not very big. You know, when we say we need pollinators because they pollinate our agriculture, that is partially true. They pollinate, actually, it's about 12% of the plants we eat. But, you know, people think then, well, if I don't live next to a farm, I don't need any pollinators. Not so. They pollinate 80% of all plants and 90% of all flowering plants. We need pollinators everywhere we need plants, which is everywhere. So forget about agriculture. We need pollinators everywhere, including where we live. This is a great way to do it. Here's a bigger one. This is a design by Drew Latham. Imagine the amount of life that is here versus the amount of life that is here. Can municipalities help us live with nature? Of Of course they can, and more states and municipalities are doing that. Minnesota has a cost sharing program to convince people to reduce or totally replace their lawn with appropriate prairie plantings up in Minnesota. They're helping people pay for that. Florida's paying residents of a particular island to let burrowing owls burrow in their front yards. This is the way the endangered, of course, the burrowing owl is a listed species. This is the way the Endangered Species Act should have been written, with carrots rather than sticks. If you have an endangered species on your property, you get paid to be a good steward of it, rather than fined because you might do something. Missouri and Fayetteville, Arkansas have a bounty on calorie pears. Prove that you've taken down a calorie pear and they give you a free tree replacement. The San Antonio water system is giving people $100 coupons to plant water efficient plants in Texas. Buffalo's paying people $100 a property to put in native plants. So it's happening all over the place. And then we have those big lawn replacement programs in the far west, particularly California, up to $2 per square foot rebate for getting rid of your thirst tree lawn and putting in appropriate xeric plants. I think we made 3 missteps in the early years of conservation. And the first is that we've assumed nature's important, but not essential. Not essential, which means when resources are short, when push comes to shove, nature always loses. And of course, resources are always short. I went to the Cincinnati Zoo before the virus broke out, and there was this wall-sized poster there, which to me epitomizes what our society's take on conservation is. We want to save wildlife for future generations. This is what Teddy Roosevelt said. We got to create national parks so the future generations can enjoy them. That's true, but to me, that suggests nature's there just for entertainment. It's much more than that. We need to save nature so that we have future generations. It's more urgent than entertainment. We've assumed that humans and nature cannot coexist. Now, we talked about this, but if you do that, that restricts conservation to areas where there aren't any humans, which means it's condemned them to failure, because those areas are too small and too isolated to sustain the species that we need. David Quammen has an excellent analogy between a Persian rug and an ecosystem. This is a functional Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, none of which are acting like a Persian rug. And that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. And I hate that language because it suggests they're places on planet Earth with no ecological significance, so we can do whatever we want to it. Not so. Every square inch of the planet has ecological significance, including our yards. So what we have to do is glue our rug back together again. We've got to put plants in these no-man lands in between viable habitat, and we got to use those keystone plants to make them such good habitat that they're not just biological corridors where plants and animals can move back and forth. They can live there. In other words, we are going to start to live with nature. We're going to share our human-dominated spaces and make functional ecosystems once again. Our third misstep was to leave Earth stewardship just to a few specialists. We didn't see it as an inherent responsibility of everybody on the planet. And I have no idea why, because everybody on the planet is entirely dependent on the quality of the Earth's ecosystems. So why wouldn't everybody have the responsibility for being a good Earth stewardship? I have no idea. Stan Rushworth, a Cherokee elder, once said that the Western settler mindset was I have rights. The mindset of indigenous people is, I have obligations. You are not born with these mindsets, you're taught them. Now, we are really good at teaching the I have rights part. We've been terrible at teaching the I have obligations part. But we have to get better because time's running out. It doesn't mean that you have to save biodiversity for a living, but you really can save it where you live. I love this approach because it empowers each one of us. Right now, so many of us feel powerless. The problems facing us are enormous, and it is so easy to feel like one person can't make a difference. But in this case, the cliche really does work. One person can make a difference. Go out and plant that oak. Plant any of those keystone plants. Shrink your lawn. Put in a pollinator garden. Get rid of your invasive species and watch nature come back. One person can do that. It makes each one of us an important cog in the future wheel of conservation. It also shrinks the problem down to something that's manageable for each one of us. Don't worry about the entire planet. You will get depressed if you do that. Just worry about your piece of the planet that you can influence. If you own property, that's obvious. You start there. If you don't own property, help somebody who does. Volunteer for a land conservancy. Volunteer for a park or a preserve. They're all underfunded. They all need help. So as property owners or as volunteers, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we decide to do so is going to determine nature's fate and ultimately our fate as well. And I've convinced my grandkids that you are nature's best hope. I hope I've convinced you as well. Thanks very much.
Thank you so much, Doug. That was, it's inspiring, and it is obtainable, and it's within our reach. And the timing is good. We still have a couple of months to think about those changes, small or large, that we're going to make in our own yards, in our own back, in our own land that we manage. You're from Pennsylvania. And you're speaking with folks mostly, I assume all from Connecticut right now. And we've done a very poor job of managing our white-tailed deer population, probably like Pennsylvania has.
Yeah, like everybody.
So if we look at those patches in our yard, our landscape, and we want to change the plant palette in those places that are really good for moth, for the food chain, which species are the best at being deer proof, or is there such a thing? How does someone like that, how do we coexist there? I'm not talking long-term about managing the white-tailed deer population. I'm talking.
Except that is the solution. I mean, that would be like fighting the coronavirus by, we're going to wear masks, but we're never going to have a vaccine, which means you're never going to win. So we do have to control the deer population for a number of reasons. And if we landscape with only plants that deer don't eat, and there's some of them, things like spice bush. That's why the understory, the native understory of our forest now is almost entirely spice bush. It's spice bush and invasive plants that the deer don't like, because they eat the natives preferentially. But that means we're planting plants. There's a big correlation between what deer like and what insects like. So if we only plant plants that deer don't like, we're gonna again have failed food webs. So the solution is to get the deer populations down. What I've done at my property, rather than simply planting plants that deer don't like, is I put cages around them till they get past the point where the deer can harm them. And I know it's ugly, and I know it's a pain in the neck, but short of getting rid of the deer, I went outside this afternoon, 7 deer standing right there. So it's a tough problem, and it's a tough problem because of the Bambi effect. We've got all these good ecological reasons for bringing deer numbers down, but we have emotional reasons for not doing that, and the emotional reasons have been winning, and they win in my house too. I mean, my wife will not prevent or will not allow hunting on our property. So I understand it, but to get deer-proof plants is you're going to defeat the overall goal if you go that route.
Okay.
I know I'm not answering your question.
No. Because I do have I use some of those tomato cages. Around some plants that I put.
Well, I get big the galvanized 5 foot wide cages with the squares this big, and they last forever. So then you move them as your tree. I use it mostly on trees and things. So.
Terry, can I ask another question before
Sure.
I open it up?
Go ahead. Yeah, absolutely.
Because if say there's a huge infestation of invasives, and I'm thinking, say, something like Phragmites. What is the cost benefit? And I think a science person can answer that. That's a good thing. The way the benefit versus the drawback of using an herbicide like a glyphosate to get rid of those things and to replace it with. Obviously, we know what the benefit of that is. Is how bad are those herbicides?
I wish you hadn't used Phragmites as an example, because it's one of the toughest. And it's also associated with water, which makes it particularly hard to control. There are all kinds of invasives up on the away from water that are far easier to control. You can saw them off, cut them off at the base, and then paint the stump with an herbicide. So you're using very little material, and that kills the roots, and then it's gone. You can do that with Phragmites too if you want to paint each stalk. Otherwise, you get into big spraying, which there's a schedule. You spray, burn, mow, spray, burn, mow, and in a couple of years, you've killed your Phragmites. But it's a big deal. So, the cost benefit, the cost is that you are using a toxic material. There's evidence, there's good evidence that if you misuse it, there are real costs to that. But one of these days, I want to actually go out to like autumn olive, cut it off, paint the stump, and maybe 2-3 weeks later, take a soil sample right next to it and see what has actually gotten into the soil, so that I can have numbers. I can say, well, this much got in the soil or nothing got in the soil. I suspect it's not much, because often that painting doesn't even kill the plant you're trying to kill. You got to do it again. So it's not much material. I don't spray myself because you always hit non-targets, but it's a touchy subject. And if you want to avoid herbicides, I understand that. Here's the cost of me avoiding it. When we bought our property, we had bittersweet with stems this thick, and I didn't want to use any herbicide. So the day we signed the papers, I went out and I sawed off those big bittersweet vines, which of course killed everything above the ground. The next year, from giant rootstocks, about 80,000 bittersweets came up. And 20 years later, I am still fighting those little things that come up from the roots, because I didn't kill that rootstock the first time. So that taught me a lesson, and if I don't continually fight it, they'll all grow into giant ones again. So there is a cost to not killing the rootstocks. If you can kill the rootstocks with vinegar or salt, or covering them with black plastic, or repeatedly mowing it or cutting it back, great. Herbicide's the easiest way to do it.
Terry, do you want to take?
Yeah, someone had a question that I mean, we have so many questions, like, oh my gosh, I doubt we'll get to all of them. But David's asked, can you list 5 or 10 small shrubs that are relatively easy to propagate by seed or cuttings that are great for caterpillars and others? It sounds like most of the people here are in New England, although we do have some people from Wisconsin, but really mostly, I guess we would say the New England area, Connecticut, Massachusetts.
You see this book? It's Ooh. Essential Native Trees and Shrubs of Eastern United States. And the first, you open it up, and it's got list after list after list of all of the options in our area and what each one of them does. It's the best source I know of. It's by Tony Dubb and Ginger Woolridge, in terms of picking the plant that is going to work in your area that does the most things. Shrubs are tough because we don't have that many species of shrubs. We've got viburnums. There are 103 species of caterpillars on viburnums, like Viburnum dentatum and nudum and those. So that's a good example. Witch hazel is there. It's not a great example because there's very few things that can eat witch hazel. So actually, that's one of the things that deer don't like very much, but either do many of the insects. But it's a good understory tree. Our dogwoods, any of the species of dogwoods are good understory trees. They're not really shrubs, but there's certainly options.
Also, Aronia.
Aronia, clethra, that's sweet pepper bush. Button bush, all of those guys are great for pollinators. None of them are great for caterpillars. They host some, but none of them are keystone species. So the shrubs in this part of the world are not going to be the great caterpillar producers. If you look at a healthy understory, and it's got to be one that don't have all those deer, the most of the understory is comprised of canopy trees that are small, just waiting for a light gap so they can grow. So it looks like a shrubby layer, but they're small oaks and they're small hickories and they're small this and that birches. Those are the ones that are generating most of the food. But there are a lot of shrubs out there, and I really do recommend that book, Essential Native Trees and Shrubs, because it'll give you ideas that I have not just given you. Our ilex, things like Ilex verticillata, they can grow in wet areas. Ilex glabra, again, great for pollinators, make good berries for the birds, but very few caterpillars eat them.
It's actually just someone said man, this chat is like so huge. Someone just said the Lady Bird Johnson Wildflower Center offers native plant lists for every state online. So that's a great resource.
And of course, that's what that Native Plant Finder does too, for every county in every state. So
wow, every county.
It's all there. Yep.
That's fabulous. Oh, so and John, when you see a question that you want them to answer, just jump on right in. Margaret was wondering, 90% of insects are plant specialists. Is that 90% of all types of insects, or 90% of all types, or 90% of all the insects?
It's the insects that eat plants. So it's 90% of the herbivores. And most of the data has been gathered on the Lepidoptera, so the caterpillars. There's sucking insects, so things like aphids and plant hoppers. It's probably a lower figure there because with their stylets, they can avoid the chemical defenses easier. They can go straight into the phloem, or the stylets actually move around a lot, and they can avoid the vacuoles that have the nasty compounds in there. But there's still a lot of host plant specialization with the suckers as well. But those suckers are only minor parts of food webs anyway. So the major parts of the food webs are those host plant specialists.
I got a question here from Alice that's asked about if you could talk about keystone plant species for wetland habitats, for wet soil. So, we might think of a red maple swamp, for instance.
Right.
So maybe
maples are way up there. Willows would be the number one. All the species of native willows, they're tied with prunus in terms of being keystone species. 456 species on our native willows. So that'd be the major wetland one that I would go to. River birch is, I don't know if you call that wetland or not, but that's very high. Poplars and cottonwood, growing along rivers. Cottonwood is certainly a keystone plant, certainly as you move a little farther west. But those would be the major ones.
I have another question that is very thoughtful as well. Is there's a lot of second growth forest, probably all of Connecticut is, but how do we transform those areas to become more diverse? Is it just different?
Well, second growth just means it's been logged. It doesn't mean it's less diverse. Now, if it's been replanted as a tree farm, then it's not diverse. But it's actually funny when you get, it's not funny. Here's what people are thinking. We keep changing our minds, but we used to think that the original pristine state were the forests that we saw when Europeans first came to this country. Of course, those forests were being managed by Native Americans who've been here 14,000 years. So that's a long time. But it wasn't that long ago that we had really large Pleistocene mammals all over North America. There were 3 species of elephants, mastodons and woolly mammoths. There were like 42 species of rhinoceros in the world. Giant sloths, giant beavers, all these things, herds and herds of giant bison. They all were eating plants, and they kept there weren't dense forests. The thinking now is that it was much more open, much more savanna-like because of all of these giant grazers that were out there and very numerous. They all disappeared. So people argue, did humans wipe them out or another asteroid or whatever, but they're gone. And that changed the nature of a lot of those forests grew very dense. When you have a dense forest, it eliminates light, which means there's not much growing underneath those canopy trees in a dense forest, and that reduces diversity. In a savanna type landscape, you've got all those big trees, but there's space and light in between them, and that's why prairie plantings came all the way to the Atlantic Ocean. We had the plant diversity was far higher in a savanna landscape and anything that's managed that way than in a closed canopy forest. So that's where the diversity comes from. It comes from the edges of forests where you've got a lot of light, or a more open situation where you've got a savanna-like landscape, because it increases plant diversity, and it's plant diversity that increases the insect diversity, and then the bird diversity, and so on. So it's a new way of thinking that possibly the most diverse situation is not that closed canopy forest, but much more of a savanna-like landscape.
Got a question about suggestions for controlling knotweed.
Phragmites and knotweed, they're the two toughest ones in watercourses. You have to kill the roots, and digging them up is just about not an option, because it takes a root piece the size of my pinky fingernail to start a new plant. And you always miss that. I do know a group that is trying to control knotweed and Phragmites by cutting it back repeatedly, and I mean repeatedly, every 2 weeks. They're in their 3rd year. And it does work. You eventually will exhaust the root supply, but it is a tremendous amount of labor. So, professionals will tell you have to spray
it. How about Tilia americanus? Is it good for caterpillars?
Yes, it's excellent.
And what is that in
linden? Basswood or linden?
Basswood or linden. Okay, great.
Now, if you go to the nursery and say, I want to buy a linden tree, they'll sell you little leaf linden from Europe, because that's what they've got sitting there. So specify, I want American linden or American basswood.
Okay.
Okay, I found a question here. It's from a land trust, and they had a grassy area that was for birds, but it's gone to thorny, woody invasives, which I assume would be multiflora or barberry.
Autumn olive.
Yeah, what would you do to reclaim that?
We get so much rain here that unless you have the big grazers keeping it open, it doesn't stay a meadow. It goes through scrub, which itself is a very, that's even more endangered habitat than grasslands. And then it moves up to forest. That's called secondary succession. But these days, the things that move in first, of course, are those invasive species. If you want to maintain a meadow for your birds, people say, well, you have to mow it or burn it every year. No, you mow it a third. Mowing is usually more common in the east than burning. A third, a third, a third. So if you have an acre meadow, you take a third of it and mow it 1 year, the next third, the second year, and the third, the third year. So any one place is only treated once every 3 years. That means 2/3 of your meadow are untouched, so that they get to recolonize the one that you did control. But what about those invasive woodies? You spot control. And mowing never controls a woody anyway. The root system is there, and as soon as you stop mowing, it comes up in spades. So that's where spot control with your painting or your little spot spray will keep them down. And if you do that when they're tiny, it's not a big deal. If you wait till it's a giant, just a thorny patch, then it is a big deal. That's what Cindy had to deal with when we moved in, and it's a big deal. But so keep after it when you create your meadow. But they'll come in every single year. This is the curse of invasive plants. When we let the burning bush and everything escape our yards, we've got this constant headache until we reduce the seed rain. Now, if everybody controlled the invasive plants on their property, There'd be less of a seed rain on our natural areas, and theoretically, it would be possible to control them. There's a lot of us. We got a lot of us, but everybody have to do it. It's simply a matter of not selling them in our nursery. That makes no sense at all. And keeping them off our private property. If everybody got rid of the invasives on their private property, we'd be 85.6% done. But you have to do it. You can't leave them on your fence row and everything else. And it's not easy. I know that.
So, oh my gosh, it's 8:30. But Maggie just wanted to know one thing. How do caterpillars find the specific host plant where you planted it? She thought the meadow rue story was amazing.
The caterpillars don't find it. The adult female finds it.
Okay.
It's the moth that's flying around, and they find it through chemistry. They smell it. So they're flying around. They've got, it's really an amazing story. You've got a lot of different plants out there, and each one has a particular smell. And they fly around until they hit the plume of the smell, and they zero in on it, and then lay their eggs. But it's all through chemistry. That's what their antennae are for. And then when they land on the plant, they've got chemosensors in their feet too, to tell them, yep, you're in the right place. And then they lay their eggs.
That's so cool. Wow, that is amazing. So, I mean, it's 8:31.
I
So
don't mind answering questions longer if you.
oh, you don't?
No,
Oh, okay, great. I didn't want to
no, that's
hold
okay.
you over, but all right. John, do you have a question you want to ask? You see one?
I've gone through the chat. Have you gone through the Q&A?
I was just actually, Vicky did we already answer the, what about Japanese maples? Should we be cutting them down?
You know, Japanese maples are mildly invasive. They move not that fast. Every once in a while I get one at my property. I rank things. The things that are really bad right now, porcelain berry is at the top of my list. That moves so fast and grows so fast, and it covers everything else and kills everything. It's the kudzu of the north. You can't tolerate that for 5 minutes. Japanese maples, if you get a beautiful Japanese maple in your front yard, I wouldn't cut it down. And it's a maple. Some of our maple specialists can use it. If it dies, that's when you replace it with something better. But no, I wouldn't cut a Japanese maple down.
I have a last question that just came in about climate change. Is that affecting a historic distribution? Obviously it is, right? So are species that were considered native no longer able to exist here, I guess is the question. Over long periods of time, species are moving north slowly. Now we're talking about plants. Insects can follow their host plant very quickly. It's the plant that, it takes a generation of an oak tree is a long time. So, but there's good evidence that the sugar maples down as far south as I am, they're not handling the hot summers well at all. So their distribution, they're going to die off down here, and they're going to slowly move farther north. And that's why plants are moving up mountains where it's cooler, because it's not as cool as it used to be. So plant distributions are changing. The insects can follow those changes, no problem at all. What a lot of people ask about is should we be engaging in assisted migration, where we take southern plants and move them north so that they're here when the climate gets warm? And my answer to that is no. I don't. That's controversial, but I say no because what really is happening with climate change is increased climate variability. It gets hotter, but it gets cold too. We still have the polar vortex, and all you need is one in a winter to kill the plant you just moved north. And we're still getting them on a regular basis. Overall, we get less snow, we're getting more rain, but it's greater variability that is the biggest problem. And what we need for that is genetic variability in our plants, and they've got to sort it out. And it's one of the reasons to be cautious about the number of cultivars that you use of native plants, because they have no genetic variability in them. They're all produced clonally. So you're putting plants in the environment that
you're making plant populations without the genetic variability that's necessary for adaptation to these extreme conditions that we've given them.
Are Korean pine good caterpillar habitats?
Well, it's a pine, but of course they're Asian. That's what that Korean stuff means.
It's not native.
You know, this is another, so pine is a native genus, but that's a non-native member of this genus. And that's where you're going to get about a 65% reduction in the species that can use it. Some of our pine specialists can use it, but most of them can't.
Mm-hmm.
But again, we got a lot of native pines. Why would you use a Korean pine? Because it's in the trade. I know everybody's got to have all these exotic conifer collections. But you know, again, those things are not highly invasive. So if you really want an exotic conifer collection, that's okay. It's you know, it's when everybody does it that it's a problem, or it's when you plant something that goes out and does it on its own that it's a problem. That's not happening with Korean pines. But lots of caveats here. That's how we brought in things like the chestnut blight and all of these foreign insects that have really devastated us by insisting on planting these non-natives. And they say, well, we don't do that anymore. Sure we do. You know, when you plant something with a disease that's not here, it's like a typhoid Mary. That plant is not expressing any symptoms, so it can be in quarantine forever. You'll never know it. And then the disease escapes and we got a brand new one. So.
Mm-hmm.
I have a question about the lanternfly and tree of heaven. Just says to talk about that. I have
what? Spotted lanternfly. You don't have it yet?
No.
You will.
Oh, I've heard about that.
Yeah. It's our latest invasive insect. You know, when I say we need insects, not invasive ones, it's just like the non-native plants. They're here without their natural enemies, and then they go crazy. The spotted lanternfly is a sucking insect, and it loves fruiting. It loves plants that make fruit, like apples, like grapes. But its favorite, that's what it does as adults, but its favorite plant as nymphs is Ailanthus. So that's a non-native plant. It's an invasive. And if you've wondered why you need to get rid of your Ailanthus, this is a great reason, because you don't want it around when the spotted lanternfly comes. And if you're anywhere near an apple orchard or a vineyard, they will bless you if you get rid of your Ailanthus, because it's devastating those industries. They do eat some other plants, but that's the main one.
Is soil composition important in planting native plants?
Soil composition's important all the time, but you can restore soil. The soil scientists probably get mad at me for this, but you know, I'm looking at what happened at our own house. Our front yard is practically serpentine barrens. The soil, you know, very high in magnesium, and when it's exposed, very few things can grow there. And the bulldozers exposed it all. So I'm not trying to run a serpentine barren restoration here. So I put in lots of leaf mulch around the plants that I planted, and that inoculated the very thin topsoil. It really, essentially, I was planting in subsoil with the humus layer. What am I calling it? The organic layer that is so essential to soil, all of the mycorrhizae and everything else. And my plants have done great. So I started with you know, terrible soil, and you know, it's only been 20 years and it's good now. It's really good. And all I did was add leaf litter when I planted it. So yes, soil is critically important. The soil creatures, you know, there are more species that live below ground than above ground. It's just that they're tiny and we can't see them. But you can create good soil by keeping that leaf litter around much faster than the textbooks imply, in my opinion.
There's a growing awareness and movement. I'm organizing a plant sale in my community for local ecotype, for seeds, for wild flower, for pollinator gardens. But I think a more general question, is nativars, cultivars, their ecological equivalents. Now, I'm a nerd. I've actually read Annie White's dissertation,
Oh,
so
good.
perhaps you could speak, yeah, speak
Good.
about that.
Okay, well, those are two separate questions. Do you want to, you're talking about the provenance of your plant genotype. So that is important to get your plant to survive. Beech, American beech, for example, this is an example I usually use. That grows from Canada all the way down to Florida and all the way west to the Mississippi. If I take beech seeds from Florida and plant them in Connecticut, they grow until the first winter, and then they leaf out 3 weeks too early, and then you have a frost and it kills them. Same species, but the provenance is wrong. The genetic adaptation is for a more southern climate. So that's why it's important to plant from local genotype, because it's adapted to the stresses that you have locally. The soils, the altitude, the latitude, the rainfall, all of that stuff makes it much easier. So does that mean that you have to plant, you can only plant a plant from down the street? No, because the conditions are they're pretty consistent if you're not in a mountainous area along a latitude. That's more important than the longitude. If you are in a mountainous area, of course, when you go up and down the mountains, that changes things. So the more you can get a local genotype, the better off you are. But if you can't, it doesn't mean everything's going to die. If it's a genotype that's from too far away, it will die, and then you do it again. You try something that's closer. You don't need to do that to meet the needs of the food web. So, for example, if I have a caterpillar that eats American beech, and the caterpillar that I got from Connecticut, it can eat a beech from Florida. It doesn't care where the beech came from. It's just that Florida plant won't grow in Connecticut. So it's the provenance beats the meeting the food web needs because of the genetic restrictions in that population. If I'm making, I'm getting tongue-tied here, but now as far as cultivars go, a cultivar, of course, is a genetic variant of a native plant. Many cultivars the genetic variant was found in nature, and somebody's like Acer rubrum October Glory. That's a red maple that had really good fall color. Somebody found it and said, okay, we're going to sell that, and I'll put a name on it. It wasn't selected for it. It was selected for it, but naturally. And so a lot of cultivars come from nature, but some of them are purposely selected to make a particular trait. Anyways, we looked at flowers. We have looked at plant traits on woody plants that have nothing to do with flowers. So if you take a tall plant, you make it short. If you introduce disease resistance, if you take a green leaf and make it red or purple, things like that. The only, in our study, the only cultivar trait that consistently depressed insect use was taking a green leaf and making it red or purple. So your red leaf red bud and your red leaf penstemon and all these red leaf cultivars that everybody loves, and I don't know why, I think they're all ugly, they depress insect use because they're loaded with anthocyanins that are feeding deterrents. The others, like taking a tall plant, making it short, didn't have any effect at all. So that's good news, because in a lot of small properties, a lot of the natives are too big to use. So that gives you a little more freedom that way. But you read Annie's thesis, that pollinators are a little bit more sensitive that way. When we've got so many bee specialists, when you start fooling with flower traits, making the petals bigger, changing the UV coloration, changing the pollen nutrition and the nectar load, making an echinacea look like a zinnia, just so that we can sell plant again, chances are good that you're going to mess with the needs of particularly specialist pollinators. It's not a given. There are some cultivars that actually have more nectar and are better for pollinators, but on average, I think they depress pollinator use.
That's amazing. Can I ask one more question?
Yes.
And I don't want to keep you too late. But Lori said she has many plants you mentioned are trees, and she can't plant trees. She said she has a tough yard, acidic soil, no sun except strong afternoon sun, and it's dry. Do you have any suggestions as to what she could plant?
Do you remember this book? It will give you exactly those conditions and what would work. First of all,
Oh,
oaks love acidic soil, so that's out. Dry, you just have to get it established. White oaks do really good on poor, dry, rocky, acidic soil. You can't just, a lot of people think a native plant, you put it in, you don't even have to water it. No, you got to get every plant going. You got to get them established. But there are native trees that can grow in all of those situations. Pines like acidic soil as well, and they grow in sandy soil, which is always dry and well drained too. So that would be another option. I bet you white pines would do just fine there. Don't give up. Yeah, I mean, what'd you say? It was shady too?
strong afternoon sun, but yeah, other than that, not a lot of sun.
Yeah.
So
no sun is a bigger challenge than this soil type.
Okay.
Yeah.
Great. Well, I have to apologize to folks. I mean, it's 8:46, so we should probably sign off. But thank you so much to Doug for being with us tonight. For those of you, I am recording this. I'm going to do my post-webinar wrestle with our YouTube channel and get this recording up there. Hopefully it should be up there tonight. I will email the link out to you. The other thing we have coming up actually is we have a webinar with Reverend Lennox Yearwood, who founded the Hip Hop Caucus, and Dr. Catherine Hayhoe, who's obviously a very well-known leading climate scientist. They're doing a webinar together on Thursday, February 4th, that you're all welcome to come to. Our webinars are free. If anyone wants to make a donation, we obviously gratefully accept it, but we really want to not have any barriers for participation, so we make all our webinars free. Thank you so much, John, for moderating. It's just a real pleasure to have you. And Doug, again, thank you so much for being with us. And everyone who tuned in, thank you so much for joining us. I hope you feel as inspired as I do. I can't even wait. I wrote the name of that book down, and I'll send that out to everyone as well. And I can't wait to order it.
Okay. Take care.
All right, everyone. Thank you so much.